Hello, and welcome to our presentation on our heart rate and oxygen saturation tracking device, the Vitals Mouse. Today, we will give a breakdown of the design process behind our device, as well as give a brief demonstration of the mouse in action. I'll hand it off to Mikah now.
I'm Mikah Jones. What is the problem? COVID. Not enough of individuals are tracking their vitals when working at home or when using their computer or laptop. This is especially more prevalent now when we are in the midst of a pandemic, when more people are working virtually from home or just staying at home. It is important to keep track of one's health to make sure that we are staying healthy and do not require medical attention. As we continue to stay and work at home, our daily activity decreases, so we need to make sure we maintain our health and not suffer from it. So what is our solution? A mouse.
My name is Ahmadshah Hazrati, and I will be talking about our solution for our project and why we choose the mouse. So why a mouse? We aim to solve this issue by allowing users to track their vitals while working or gaming for long hours at their computers. As we all know, increased screen time has damaging effects on health, but it is inevitable. We would like to provide a mouse to easily track our vitals, such as detecting heart rate and oxygen level. The mouse can retain data that could be shared with medical professionals. This mouse also consists a user interface UI program built in with the mouse to provide an easy access to vital history analytics and data exportation.
For our design process, we took into account data from our survey, which the results were as following. 70% of respondents used a computer with a mouse at least once a day, and 54% used the computer with a mouse for more than 2 hours each day. From this, we can see that a large percentage of people use a mouse daily, and the majority of those people use said mouse and computer to do so for more than 2 hours a day. Cost is important, so we don't want super expensive components. There exists one other similar mouse, but it is branded as a luxury product and is not in the price range of a normal user, nor does it encourage the accessible vitals tracking we are aiming for. As for the prototype, because we have no experience with ergonomics or optical sensors, and because this is a prototype, we decided to use an existing mouse as the base for our design and implement the sensor and hardware inside of it. A main influence of our design is the ability for our prototype to be easy to use. This is also why we chose to pick a simple mouse. We were keen on having our prototype to have a high reliability by having a decent quality part in our mouse and still have a price cost that beats other competitors and is still appealing to the consumer.
The problem we are trying to address is prevalent, so we aren't exactly the first to come up with a solution. Throughout the design process, we have been asked over and over again what our device does better than similar solutions on the market such as Fitbit and finger oximeters. In order to address this, we took a user survey which informed us on the opinions of potential users on the shortcomings of these devices. Keeping that in mind, we aimed to succeed where these had failed. We aimed to lower the cost to lower the bar to entry. We tried to eliminate hassles such as charging batteries and a long pulling process, and we tried to integrate the device seamlessly into the everyday life of the user.
Photoplethysmography, or a technology called PPG. Oximeters use this technology to measure pulse and oxygen level in wearable devices. The sensor measures a pulse by tracking the movement of blood vessels through the LED light. PPG can also determine oxygen saturation by measuring the concentration of hemoglobin via the light absorption of your skin.
Hello, my name is Kevin, and I would like to share our reasoning and evaluation of some of our design alternatives. We had a clear winner for our sensor choice. We chose a PPG sensor because an electrocardiogram sensor cannot measure oxygen saturation in the blood, and it's a little less accurate. We saved on cost by using an existing mouse and a wired connection, because designing our own mouse or using a wireless communication method would add unnecessary cost and complications for our user. For example, we would need a larger battery to account for adding a microcontroller and a sensor. We chose the Adafruit microcontroller because of its size, and our first two alternatives are much easier to work with, but they are far too large for our project. The Adafruit microcontroller is about the size of a quarter, and it fits easily into an existing mouse.
We have faced a few challenges while designing this system. So here is a brief breakdown of some of them. Because of the pandemic and remote learning, it was often difficult to coordinate teamwork between 5 people, especially in person. There were also issues with the parts that we ordered. There were major shipping delays due to weather, and one of the sensors arrived defective. We also had some difficulties with the I2C connection, because none of us have worked with it before. There were a lot of issues trying to establish a connection, and eventually we realized that part of the problem was that we did not know that our microcontroller did not have pull-up on SCL and SDA. Another problem was the inconsistency of the sensor. Although it is fairly accurate, it can be very sporadic, leading to long periods of useless data. This inconsistency led to problems with storing and displaying the data, and is something that we struggle to fix.
Here are the most important engineering requirements that we established before beginning work on the project. There were a few caveats with the completion of these, starting with cost. The device's products came to a final budget of $54.98, which still reached our goal of around $50. However, the most desirable result would be to fit under $50. Since this is a prototype, we can still find lower costs for certain parts. The device does work on any Windows computer. However, the process is not automatic, and the user would have to install programs manually. We were not able to implement automatic installation or drivers as of yet. The rest can be seen in the demo videos coming ahead. This is our heart rate and oxygen monitor mouse. We used a basic Logitech mouse controller, and we implemented our heart rate and oxygen sensor from SparkFun. There's 2 USB cables coming out of the mouse. One USB cable which controls the microcontroller, and the other USB cable that controls the mouse functionality. To use this product, we have to plug in both USBs into the computer. As you can see now, the sensor is fully functional. And as you can see on my laptop, by plugging in the USB from the mouse, we can see that the mouse is fully functional on its own. Now I will demonstrate how the mouse actually functions. I will be using my laptop, and unfortunately I only have one USB port, so I'll be showing you it individually. With my mouse working and my finger on the sensor, as you can see, we're getting live data results from the sensor itself. It is saying that our heart rate is at 92 and our oxygen level is at 97. As you can see, it's giving live readings as we're speaking. The sensor is built in to the UI that once our oxygen level goes below the threshold of 95, a warning will appear saying that take a breather, raise your oxygen levels. And as you can see here, the data is constantly flowing into the UI. It keeps resetting itself every second, getting live results as we speak. Now, if you want to stop this at any time, you can click the stop button and it stops your data completely.
Okay, so now we're going to do a short demonstration of the software in action. Just a side note at the beginning, because of COVID restrictions, we've had to develop some tools to help with the demonstration process. So if I click start here, you can see it just generates random values around a base range because I don't have the mouse with me right now to show those actual readings. But it's just for demonstration purposes. So at the top here, you can see the live display. On the left, we have just a graph of the recent values and then the current value that it's reading. And then here is our history view in the central area. So I can pick a date here, say the 9th, and if I click from date, it'll load the 9th data. And then if I want to go from a specific file, say if it was a patient's file, I would go in here and I would click, let's do the 16th here. It'll load the file up and show it. And then on the left here we have analytics. So it just shows some basic, just the averages. So the daily, monthly, yearly average, and then it graphs the most recent month's average value here. And then under export, if I want to go to my desktop here, we'll name this demo. So it generates a zip file that has every single of the last month's data files in it, and this is for exportation purposes to send to your doctor. And then finally we have options, so I can change the mode from USB to debug. It's currently in debug for testing demonstration purposes, and then I can also set the heart rate threshold and the oxygen threshold for the notifications, and also the cooldown. So if I wanted to turn this down to, say 60, if I close this now, you can see that the notifications are popping up in the corner. And that's about it. So with that, thank you for watching. This has been the Vitals Mouse project.